Okay, guys, week 9 of distance learning, and this week we're dealing with exponent laws. So in this case, we're doing multiplying and dividing of exponents with the same base. Okay, so the same base is the important part, all right? So in this case, it says if you're multiplying powers with the same base, you simply add them. So if we had the base of a and a, but it was to the exponent of m and n, we're just adding m and n. But a different way to look at that would be if we had the base of a 2 to the power of 2 plus 2 to the power of 4, it would be 2 to the power of 6, or 2 plus 4. Okay? So if we look through some examples here, I've already written some down and then we'll go along with it afterwards. But if you write each product as a single power and then solve if possible, we have 2 to the power of 3 times 2 to the power of 2. So that would then be 2 to the power of 3 plus 2. If we did it again, 2 to the power of 5, because 3 plus 2, and 2 to the power of 5 being 32. Okay. If we look at the next one here, we've got 10 to the power of 3 times 10 to the power of 5. So that being 10 to the power of 3 plus 5, or 10 to the power of 8. And then in this case, we've got this very large number here, 1,000,000,000,000,000,000,1 billion. Okay. In this case, we have 6 times 6 to the power of 3. Anytime it's just your number, you imagine an exponent of 1. So in this case, 6 to the exponent of 1 plus 3, or 6 to the power of 4. That then becomes 1,296. Okay. Now it says, how does this rule work? Well, simply, it's just going through all the things we've talked about already. But if you're doing this, so 2 to the power of 3 can be rewritten as that. And then if we multiply by another 2, we'd still come up with our same answer over here of 32. If we did this one over here, we'd have 10. Okay, so 10 to the 3 written out as that, 10 times 10 times 10. And then adding another 5 times, we then, if you type that into your calculator, are going to get this number. And then once again, if we did it over here, 6 times 6 times 6 times 6, we're going to get 1,296. Now we're going to get on to exponent laws when dividing. So if we're dividing with the same base, we simply look at the following. So if we have the base of a again, m divided by a to the n is m minus n. So instead of adding this time, we're actually subtracting. So it says write each quotient as a single power and then solve if possible. So we know, once again, just like we did up there, but now it's the opposite. We have 5 to the power of 5. 5 to the power of 5 minus 2, or 5 to the 2. So in this case, if we did that simple math, we'd have 5 to the 3, or 5 minus 2 equals 5 to the 3. And then if we multiplied that through, or we did 5 to the power of 3, we're going to get the answer of 125. If we continue on with the next one, and the 7, in this case, we have 7 to the 4 divided by 7. And remember what we said last time, if it's just the base, it's to the 1. So 7 to the exponent of 4 minus 1, because 7 by itself is actually 7 to the exponent of 1. So that would then be 7 to the 3. And if we did that through, 7 to the power of 3, it's going to answer or equal 343. Now this right here, the fraction, is another way to write division. So in this case, if we want to rewrite this, we can write 12, oh, sorry about that. We can write 12 to the power of 9 minus 12 to the power of 7. And then if we continued on with that, 12 to the power of 9 minus 12 to the power of 7, we can rewrite like so. Okay. And then if we finally do that, 12 to the power of 9 minus 7, or 12 to the power of 2. Okay. In this case, 12 times 12 equaling 144. So that's all for this week. Next week, we have a little bit of a heavier lesson regarding multiplication of monomials and polynomials, which we'll go over. But this week, we're just getting you set up with exponent laws, and your job is to complete the assignment. All the best and good luck this week. Hopefully you're all happy and healthy during this time, and you're continuing your distance learning with math class. All the best. Take care. Bye now.